We've got Sidewinder targeted attack against Android in the golden age of Libs. Please welcome Tao Wei and Yulong Zhang.
Thanks, everyone. I'm Tao Wei from FireEye, and this is Yulong Zhang. We will present a talk on Sidewinder targeted attack against Android. This is a teamwork with Hui, Ming, Chuangang, and Dang. This talk is about a classic vulnerability affecting billions of app downloads from Google Play, and a key step to exploit this vulnerability to its full strength. An attack can locate targets on a large scale and then control the victim device. First, we will briefly introduce classic JavaScript binding attacks, and then we will discuss about two important missing parts that turn this attack into a really powerful targeted attack. Okay, let me briefly introduce JavaScript binding and the relative vulnerabilities. JavaScript binding in WebView is designed to allow JavaScript to access exposed Java objects and interfaces. However, researchers found that JavaScript binding allows JavaScript to use Java reflection to acquire a reference to runtime object, and then they can execute arbitrary commands on the device. So if attackers can control the websites or communication channels, they can inject arbitrary malicious JavaScript into victim devices. One of such vulnerabilities is JavaScript binding over HTTP, GBOH for short. And all affected apps are vulnerable to DNS, BGP, and web hijacking. JS binding vulnerability has a long history. The first public report was published at 2011. At 2012, Google released a protection from Android 4.2 with API level 17. Last September, an exploit to get a remote share was published. After that, many JavaScript binding vulnerabilities were found in Android apps. Even today, there are still many apps with API level less than or equal to 16, and they are still vulnerable even on Android 4.2 to 4.4.3. Here are the stats. As you can see, in the top 5 Android ad libraries, excluding Google Ad, the top 4 contain GBOH vulnerabilities. And in total, there are more than 10 billion vulnerable app downloads from Google Play. It is, 10 billion is a really big number. Today, there are only about 1.1 billion Android users in the whole world. But from a popular vulnerability to a terrifying attack, there are still two missing parts. The first missing part is about Android context for powerful operations. And the second one is the scalable locating ability. Okay, now welcome Yulong for the first missing part, Android context.
Thanks, Tao, for the background introduction. So my name is Yulong Zhang, so I will cover the missing part 1. So I will talk about what is Android context, how to obtain Android context by exploiting JBOH, and how to utilize Android context to do powerful attacks. So Android context is the interface to global information about an application environment. So we need the Android context to do some powerful attacks, including if you want to read and write the clipboard, you want to modify the launcher shortcuts, if you want to set malicious proxy, or if you want to record audio and video, or install arbitrary apps. So I cannot say they are theoretically impossible, but without context, it's extremely challenging to do those tasks. So, like other researchers, we have tried many different methods to obtain context via the JavaScript bridge, but we suffered those failures, so I want to share with you. So the first trial is to use ptrace to do code injection and to get context from the victim app. But the problem with this is if you are not root, you can only ptrace your parent or child process. And On our testing firms, we found that it requires the target process with the debuggable set as true to be able to p-trace. And the second method is to start a new JVM and create a new context to do things. But the problem is the dynamically created context has no statically registered permissions. Say you cannot exploit the record video without the video permission. And the third trial is to do remote call through the binder directly. But the problem is you cannot pass the Java objects to the remote calls in this method. And the fourth trial is to use reflection in the JavaScript bridge to directly obtain context. But this has issue as well. We cannot register Java callbacks, which is required in recording videos, taking pictures, etc. So our final solution is like this. So we use the JavaScript bridge loading method to load JNI binary into the JVM. So in this way, we can both obtain the context and we can obtain a Java environment to register Java callbacks. So with Android context, we still need more tricks to do both powerful and stealthy attacks. Read and write to clipboard is easy because in Android, clipboard is word accessible without permission. So you can easily read and write the clipboard and still maybe pasted password or sensitive files from the clipboard. And even you can temper the information on the clipboard. And this vulnerability is discovered by us. So in Android, normal permissions may have dangerous impacts. Those two permissions allows attacker to modify the launcher. For example, you can query, insert, delete, or modify the shortcuts without the install shortcut or delete shortcuts permission. We have notified Google, and Google has fixed this until recently. And you can also use reflection to change the proxy to point to the malicious proxy to steal the traffic or inject malicious traffic. And you can do background surveillance by record video, audio, or take pictures. And this is somehow challenging because through the JavaScript bridge, your dynamic code, you cannot assume that there is a surface view there already. But we found that on some phones, you don't really need to register a surface view to create a surface view to take pictures. And the other phones, although they check this, you can online create a dummy self view to take pictures and record videos on the fly. And you can also use the two permissions, get accounts and use credentials, to install arbitrary Google Play apps without the user notification. So this vulnerability is discovered by Daniel, and we integrate this into the attack. To hit the live demo time. So on the left part of my screen, you can see my Samsung Galaxy S4 with Android KitKat. I casted my phone to my laptop, and you can see that on the home screen there is an anonymized Google Play app. For security consideration, we will not review the app's name and icon here. So if you open the app, you can see that in the bottom of the app there is an ad frame. So this is where we can explore the victim's phone, because the ad tries to enable the JavaScript bridge where the attacker can inject malicious code. And on the right-hand side, you can see the attacker's control panel where the attacker can configure the type of the attacks. So for example, after hijacking the DNS or some more powerful attacks that Tao will introduce later, the attacker can redirect the ad to its own malicious server. And it can also try to control the victim's behavior. For example, it can select take pictures. And later, if you open the app, you will see the pictures uploaded to this panel. So let's try to open the app again and see what will happen. So there we go. You can see a frame popped up saying, congratulations, you are owned. And you won't see me in the real world attack, of course. And after waiting for a while, you can see this picture has been uploaded to my attacker server with the GPS location. So with such kind of location information, you can identify the victim, the location of the victim. And you can see this is my Mac Pro's keyboard. And the attackers can also control the victim to record video, for example. So let's try to reopen the app. So again, you will see this congratulations message. And in the background, the victim phone is taking videos. And in the real world attack, again, the victim will not notice the background attack. So again, there is a new file uploaded to the attacker's server. So you can see some of the audience are here. And you can also try to control the phone to dial numbers. So for example, on the other casting screen is my another testing phone. And later you will see that this phone will get called. So let me open the app again. Fabulous. It's calling the victim's phone. I hope I typed in the correct number. Okay, there we go. There's some delay. So you will see that the victim phone is controlled by me to dial in the arbitrary number that I instructed the phone to call. We have more details about this demo, and you can go to YouTube to search the how a mobile vulnerability turns your phone into a surveillance device. We uploaded here. So that's the demo, and I'm going to pass the presentation back to Tao.
Thank you, Elon, for the amazing demo. And in the next, I will talk about the second missing part, scalability of locating targets. The classic method of locating targets for GPOH don't scale. Attackers need to put fake Wi-Fi hotspots at Starbucks and at Black Hat. However, there are too many potential locations. This map shows all the Starbucks in the South Bay Area. And there are other places, such as CEO offices, meeting rooms. Not easy for attackers to put fake Wi-Fi hotspots. So again, other libraries help. Here are the stats for other top 5 other libraries, excluding Google Ad. As you can see, the top 3 of them upload GPS location through HTTP in plain text. Here is an example. You can get the GPS location information in plain text in the HTTP traffic directly. This is a GPS location, and this 8 is the precision. Today, the GPS location precision is only 8 meters, and it is enough to locate most important rooms. And I believe many CEO offices are bigger than 8 meters. So in this way, we get Sidewinder targeted attack. Attackers can target potential victims only by monitoring the ad traffic for GPS location, and then inject malicious JavaScript code only into the victim traffic and skip other traffic. In this way, normal users can hardly be aware of this attack. And the monitoring can utilize high-speed substring matching for internet traffic. And there are other well-known ways to redirect traffic into the monitor, such as DNS hijacking, BGP hijacking, and ARP hijacking near the ad servers. And combining with root exploits and root buckets, they can bypass most of mobile security protections today. And here are the stats. More than 3.2 billion app downloads from Google Play are exploitable and targetable by Sidewinder targeted attack. How about the future? Google introduced a new protection to disable get class from JavaScript at Android 4.4.4 at June. It will defeat common reflection of JavaScript binding exploits, but it's still open for other exploits. However, developers and vendors are slow to adapt the new API and the new Android versions. As a result, this threat will shadow Android users for a long time. Here is the conclusion. JavaScript binding vulnerabilities affect more than 10 billion app downloads from Google Play. And attackers can conduct many powerful attacks after getting Android context. And the Sidewinder attack can locate targets accurately by monitoring GPS information in ad traffic on a large scale, and then control the victim devices. More than 3.2 billion app downloads from Google Play are vulnerable, and all the affected Android devices in CEO offices, meeting rooms, Starbucks are vulnerable to this attack. That's all. Thanks.